I am Abdullah Shatri. I'll be moderating an enlightening discussion with one of our esteemed guests, Dr. Yusra Abdulrahman, about the future of aerospace technology and its applications. Before we deep dive into our discussions, I'll start with introducing our guest. Dr. Yusra Abdulrahman is an assistant professor at Khalifa University and a member of Mufakkiru, الإمارات. She earned her Bachelor's of Science from the University of Arizona and her Master's and PhD from a joint program between Masdar Institute and MIT. She's active in the UAE aerospace industry since 2014. Dr. Yusra specializes in enhanced automation, inspection techniques, and AI application aerospace. She received numerous awards and she has published extensively in her field. In today's dialogue, we will explore the future dynamic of aerospace technology and its broad applications. So, Dr. Yusra, could you begin by telling us about the advancements of aerospace technologies that you foresee shaping the future, especially in regards of AI integration?
Thank you, Khoya Abdullah, for the introduction, and I also want to start by thanking the Emirates Center for Strategic Studies and Research for this invitation and giving me the opportunity to shed light on the aerospace and its application and future direction. And thank you, everyone, for attending this session. It's my honor to talk about this topic with you, Khoya Abdullah. Before I proceed with answering your question, let's give a bit of insight about the aerospace industry and how it works generally. So if we talk about the aerospace industry, it covers many industries. It covers many sectors. A lot of key stakeholders are involved in this field. So the aerospace industry basically covers aviation and space. When we say aviation and space, we mean aircrafts, helicopters, and drones, as well as spacecrafts and space stations. So basically, let's go a bit technical. If we're talking about the engineering aspects of it, aeronautical and astronautical. Aeronautical is the design and development of the systems related to those aircrafts. And if we're talking about astronautical, it is the design, development, as well as maintenance of the spacecrafts and the space station. Now, without any doubt that the aerospace industry is growing, it's developing, and related to these kind of technologies, a lot of future direction could happen, specifically integrating the latest technology like AI, and I'm gonna talk about some other latest technology that also I'm working on. So if we're talking about the latest, let's say, articles published by McKinsey about the latest top trends, we'll see applied AI, and industrialized machine learning, Web3, and industrializing the applications of space technology. Now, talking about all of this and knowing that it can cover commercial aspects as well as defense aspect, we see that very important like key holders and key players control this environment. The current value of the aerospace industry is around over 300 billion nowadays, and it is estimated to be over 600 billion by 2032. This means that we need to advance even more, we need to collaborate even more, and we need to integrate the latest technology with our existing infrastructure in all aspects, whether it's commercial or defense. Now, going back to your question, what are the latest advancements in the aerospace? I see that there is huge potential for drones and autonomous system vehicle, especially that we're having the Dubai flying taxi coming. And we're focused more into space applications and how to navigate and inspect remotely. There is a lot of potential for predictive maintenance and maintaining the integrity of all of these systems, and integrating AI, blockchain, mixed reality, a topic that I really like, into these applications will enhance the opportunities and the potentials of utilizing these technologies.
Thank you, Dr. Yusra. I cannot agree more. Another question. Could you elaborate on how these technological advancements are set to revolutionize sectors such as space exploration and aviation?
شكرا أخوي عبد الله. Now, talking specifically on how it can revolutionize those applications, now my area of specialization is inspection, whether it's related to predictive maintenance or making sure that whenever we manufacture any part in the aviation industry, well, I'm more focused on aviation, not really space, but I can also highlight some of those aspects if you guys would like to have any questions related to space applications, but let's talk about the aviation. So, maintaining the integrity of aircrafts is very important. We have people who want to fly from point A to point B. We have people who are controlling drones from point A to point B. We have private entities who uses helicopters from point A to point B. So for you to get on a plane and feel safe from those points, there are a lot of work behind the scene. And one of these is inspecting the overall integrity of the aircraft, whether it's from engine perspective, material perspective, or the electronics connectivity perspective. Focusing specifically on how to know when to inspect a product or a system is very important. Having an applied AI system integrated into the predictive maintenance will not only help me in inspecting those materials and components and engines, but it will flag a system when it's failing or close to failing. It will help me in optimizing the planning of inspection system. It will help in saving the costs rather than waiting for the product or system to fail. So we will know in advance and we will save this cost. It will reduce the downtime of an aircraft. So instead of having an aircraft under operation for 2-3 months, maybe with the help of AI and applied AI, we will reduce that time, could be by 50%, 70%, depending on the components that require the inspection and the maintenance. So the systems that will be revolutionized magnificently is integrating predictive maintenance with applied AI, as well as the support of mixed reality and virtual reality to train technicians and engineers before things happen, so in order for them to be capable of developing their own skills virtually and inspecting in real life and real time when it happened.
Very interesting, Dr. Yusra. Yes, it's very good to adopt the emerging technology to make our life easier and lowering the cost and accelerating the development. So transitioning to the practical aspect, what are the primary challenges that stand in the way of implementing those futuristic aerospace technology, and how can we address them?
Thank you for your question, Khoya Abdullah. This is a very important question because from a perspective from an academician, it is quite challenging. So if we consider the complexity of the systems, and we're talking about an aviation sector that tolerates zero errors, we need to operate in an environment we have no rooms for any failures, because we're talking about human life, right? So for example, if I'm working on a project that requires me to predict the failure of a material on an aircraft or an engine integrity, I need to make sure from a research perspective and deploying this research into the facilities of the industry that has no error. And translating it to reality requires huge effort, and maybe we can talk about that later. Now, talking about the challenges, as I mentioned, complexity of the system. So if I'm looking to integrate a mixed reality perspective and technology into an existing infrastructure, let's not only talk about research and development, but translating that into the industry requires huge effort of understanding the existing infrastructure, understanding the new technology, and understanding the original technology. And making these links are quite challenging. The second aspect is having, I'm not going to say testing facility, because a lot of existing universities and research centers already have the facility, but let's talk about the real infrastructures where real aircrafts go for maintenance. We need to integrate the knowledge from different sectors together in order to understand the reality of inspection and the reality of integrating those components. And this is another challenge because it falls under privacy, it falls under knowledge sharing, it falls under regulation, and clearances is one of them, for example, if we go as simple as that, because it requires a lot of interaction, close interaction with the technicians and the people in the industry, with the academicians, researchers, as well as the government regulatory bodies. Another challenge is data. We do have data, but how much data do we have? And if we're talking about AI and applied AI specifically, because when talking about applied AI is that we need to apply the AI technologies in industrial application that can be revolutionized. And access to data, again, falls under security and availability of data. How far is our data going? And how much data we need to train a new model and to train a new system? For example, if I am working on something that helped me use a convolutional neural network, for example, that requires thousands and thousands of images, do I have access to these data? Do I have access to the facility that helped me acquire those images? This is a very big challenge when we translate it into research and development. I'm trying to think of something that I can use as an example here. Okay, let me give you an example. So we have existing collaborations with local industrial partners who are focused on the aviation industry, and having an open communication is always needed, and it is there. However, there are priorities, if we be very honest with ourselves. There are priorities in terms of what we need to work on to improve and develop, and what can wait. And sometimes time is a factor that we cannot control, because technology always evolves very fast, and we might not have enough time to wait and keep things on hold, so we need to prioritize. And when we talk about data again, we need to make a decision of what to start working on first, and by the time we move to the next topic or the next aspect of inspection, specifically in this case, it might be out of date. We need to integrate new technology and new trend that maybe can help me faster in this case. Web3 can help magnificently in this aspect, because Web3 and blockchain is mainly focused on decentralized system and data sharing. And if we implement a great blockchain network that can link the stakeholders and the key players in such development, we could solve one of these challenges.
Thank you, Dr. Yusra. Now I'll take you to, or this discussions take me to the last question, the calibration. As you know, Dr. Yusra, calibration is the key for rapid development and success. In your perspective, Dr. Yusra, how can academia, industry, and government best work together to foster and accelerate the development and the deployment of cutting-edge aerospace innovations and technologies?
Thank you, Khoya Abdullah. And this is something that not only is important, but it is the key to develop any new technology with let's say, with passion and being sure that it will be translated to reality. Because if we don't have academia, industry, and government working together, everyone will be just working in their own bubble. So we need to have a combined platform where they all integrate in order to translate any research that is cutting edge and supporting our industry, specifically the aerospace industry, to translate to reality. So let me start from research centers. So I'm sure there are a lot of research centers in the UAE that combines all these three stakeholders, and one of them is Khalifa University. Since I'm coming from Khalifa University, I can highlight a bit of knowledge about that and information. So we have research centers that support research development that combines industry partners as well as access from government to these information, so we can translate it into innovative startups or innovative solution that can translate to one of the industries. Why is it important? It is important because it gives the academia access to knowledge and data and information from the industry. If we work without having those information and this access, it will not be translated into an actual solution. So we always seek to see what the government is looking for, what is the strategy of the UAE, and what is the strategy of those industry partners. What is it that needs solving? So we look for problems. We need to go and seek those problems. Problems are good, they provide opportunities, right? So whenever we have a problem, we try to see how we can solve this problem. Is it something that can be done right away with the existing technology? Does it require intervention and adding applied AI, blockchain, and all of these latest trends in order to make it even better? So access to facility is very important. By having the collaboration, they provide us with the access to those facilities to see the real world problems, so we can provide the solutions. Funding. Now, without funding, research can go so far. We cannot go to applied, industrialized system without having an actual funding. It will always be a level 3 or level 4 technology readiness.
So it's always problem number one for academia, the funding. They always.
Well, you're right, yes. But before it becomes problem number one, in my point of view, problem is the first thing. So if I see a problem in a certain industry, then I'm going to ask for funding. But you're right, absolutely right. Without funding, we cannot have the human capital that will work on this project. We cannot have the equipment that will support in developing the research. Training was one of them. So if I know the problem, I need to understand how it works. I need to understand how the industry is conducting. Let's go back to the predictive maintenance. If I'm visiting a maintenance and repair company, before I start proposing solutions, I need to understand how they operate. I need to understand their processes, because every company has a certain process, and understanding the process will help me find the gaps and will help me find how I can accelerate the process. And the intervention of the government here is what makes it become a reality. So government is always supporting initiatives, and it's always needed as a third perspective. So we discussed funding, we discussed access to facility, we need to discuss training. So when they provide us with the process, after we develop the research, we need to provide them with the process of the solution. So the training is both ways, actually. So them telling us how they are doing it, and after we develop the research, we tell them how to do it better. Something that is also very important here, young talent. Not only we develop the products and innovate in the existing technology to help the industry move forward, but we need to create better equipped human capitals for the future. So having collaborative program for young students, let's say, whatever the age is, and having combined effort in order to create programs that are overseen by the government, the industry, and the university, will prepare well-equipped young generation who are gonna move the aerospace industry forward. Even if we're applying AI, we're applying blockchain, robotics, it doesn't mean that the human capital is not important. This stage is, as they say, is the robotization and the latest trend of AI age, but without having ready young talent to move it from the current stage forward, it's not gonna move any forward. We're just gonna be relying on the existing technology. So here, where we have the three combined efforts to move the whole industry forward.
Yeah, thank you, Dr. Yusra. I cannot agree more, and thanks for UAE leaders. Human capital always is their number one focus. Thank you, Doctor, for your insightful and fruitful discussion and dialogue. And now we open the floor for Q&A session for our audience. Please feel free to ask Dr. Yusra any question related to aerospace technology and its applications.
Hello, Dr. Yusra. Thank you for your insight. You mentioned mixed reality, and it struck to me. I want you to elaborate more on what is this technology. Why do you think we need it, and how would it go wrong?
Thank you for your question, and it's a question related to a topic that is very close to my heart. So mixed reality is a bit different from virtual reality. So virtual reality is basically you are in a virtual environment to see something different than the actual reality. Mixed reality is having a combined reality between the existing reality and the virtual reality. How it can help the aerospace industry? There's a lot of potential. I'm going to start with education. So now we have astronaut Dr. Sultan al-Niyadi going to space. All of the kids are inspired by this mission. So having a mixed reality environment designed specifically for ages depending on the students that you would like to target, where we can mimic the atmospheric realities of those conditions, will help the students and the kids understand his experience in space and understand the technology that, like the space station, how did he move from Earth to the space, the time he spent there, the food he had. So designing a mixed reality for this specific application will inspire the young kids so they become innovative themselves, creative, and maybe at some point take a path where they would like to learn more about aerospace technologies and space technologies and go for a degree, for example, or work in the aerospace sector. This is just one example of it.
Hello, Dr. Yusra. We're really happy to have you here today.
Thank you so much.
My question for you, you've addressed so many challenges related to the industry, and you mentioned something which is integration. So if you were to propose something in the society and to Khalifa University or to UAE leadership, what would be this initiative or a platform you would like to establish?
Currently, integrations, but not to the level that we would like to see. The UAE is leading in these aspects, and we have a lot of industries leading the, let's say, the way and the path into translating technology and research and developments from the labs to reality. And we have worked on several projects with Khalifa University. However, sometimes we have challenges in terms of priorities. Now, industry have their own priorities, and having certifications of those technology to be ready from the lab to the market goes through stages, and one of them is certification. And especially that the aerospace industry is a very stringent, and the policies and the regulations internationally, not only in the UAE, require a lot of follow-up process of approvals, going from readiness in the lab to readiness in the facility to readiness from a Boeing point of view or an Airbus point of view takes time. And if I would propose a platform, maybe I would propose maybe a government regulating body who overlooks specifically this as an initiative, so we can accelerate in this aspect and have people who are specifically looking for those technology that are ready for the market to accelerate the certification and the accreditation process of these technology. Thank you.
Thank you, Dr. Yusra, and thank you for everyone in the audience for joining us today. We look forward to seeing you at our future events. Thank you.
Thank you so much.